Did you know that humans are getting shorter? What does bacon and eggs have to do with the CIA successfully overthrowing the government of Guatemala? Which country has a life expectancy of only 14 years old? Learn the stories behind these and so much more in my new book, Facts That Aren't True. Don't forget about my other book, Rational Answers to Stupid Questions. Link in the description.
Based on my research, right? Nobody really agrees, or I haven't really read an article that gives like a definite, like, okay, this is it. Like, okay, so what I'm asking is, how did life start?
Oh, well, that's abiogenesis, not evolution. But we
But it's
don't know
gonna lead
that. We
to it.
don't know that precisely. It's like asking what made the universe begin expanding or whatever. We don't know, but we do know that the universe is expanding. We we know that as much as we know that the Earth orbits the sun rather than the other way around.
Right,
But I mean, I can give you a low resolution answer: chemistry, because we know that's how life works.
right. See, the only, I guess, the reason I'm bringing it up, I know you said it's a biogenesis and not evolution. I think it's still necessary to it. Like in the example you gave, you said we know the Earth revolves around the sun, right?
Yeah, and
We know that, right? But I think it's also
yeah, and you
necessary.
don't need to ask where did the Earth come from to know that the Earth orbits the sun.
You don't think it's necessary to ask why, at least?
No, it's valuable information, but it doesn't change the probability of that claim
Right.
being true in any
But
way.
but why it does so? Don't you think that's necessary to why it's even doing it in the first place?
No, like if let's say that God doesn't exist and the Big Bang is true, and the reason the Earth exists is because gravity coalesced material together and formed a planet, and it did the same thing for the sun, and there's this force called gravity, and that's why Earth is orbiting the sun. Let's just put that over here. And over here, we're going to construct an explanation.
Right. So really
The
quick,
other
I
day,
don't mean to cut you off, sir. I just want, before you move on, right? You just said that because of gravity, right?
yeah,
Earth was formed, matter came together, and because of gravity, started to revolve around the sun, right? So, like,
yeah.
that's what I was asking. Like, why? That's very important.
Well, not really.
Without
And let me.
gravity
I can
in our
actually.
equation, it wouldn't
I
make
can
sense.
tell you. I can tell you why this isn't super important. And you sound like you're underwater again. But it only takes me a second. So that's one. That's one thing. Over here, let's build a different explanation. God miraculously made the earth and the sun, but the earth still goes around the sun because of gravity, because of everything we observe today. So, explaining how it got the way it is does nothing to it changes the story of how it got there, but it changes absolutely nothing about our understanding really about the thing itself.
No, it does vastly, right? Because at a point in time, well, even till this day, some folks believe that we go around the sun, right? So that
Mm-hmm.
understanding of what causes the movements that we perceive, whether we perceive it's the earth moving, or it's the sun moving around us, right? Until we know what causes that, why that is so, we won't really have a perfect understanding. That's why there's confusion. That's why some folks still think that that the sun is the one moving around the earth, right? Because they don't understand those uh, preceding things like gravity and stuff. So with evolution, right? Understanding how it started, life, right? Because it's life that's evolving, right? So, like, for me, at least personally, right? If I'm tracking how this life is changing over time, I think it's very necessary to ask why it even started or how it started, at least. Now, I'm not saying you have to know that, but I'm saying it's a very important question, though. You can't just ignore that.
I don't ignore it. I'm just telling you that if God put the first living thing on the earth billions of years ago, and then God just walked away and evolution's been going on ever since then literally everything we know about evolution is still true, except like some details about maybe the very beginning you could argue, but literally like the entire history of life on this planet is described by evolution from the onset of the beginning. So it fundamentally just doesn't matter the creation versus, or the abiogenesis versus creation thing. Now it would matter. It would matter if you said that God created all life only 6,000 years ago and organisms aren't related. That's a big deal, and that's easily falsifiable. But otherwise,
right? But
it's not necessary.
Right. Okay. So somebody in the comment just said abiogenesis deals with non-living matter. Evolution deals with living matter. I guess to clarify, I'm going to ask a follow-up question. Do you believe that living matter, right, came from non-living matter?
There's really no such thing as living matter. There are living organisms.
I'm speaking how the person who asked the comment is speaking.
Yeah, life came from non-life in a simplified version of the same way that life comes from non-life today.
Right. So then again, that means that so abiogenesis, right? He's saying that's non-living matter. You're saying that life came from non-living matter, right? So
again, the same way it still does today. Yep.
Wait, so you're saying that the same way it still does today, there's still non-living matter turning to matter today?
Yes, it's called life. Is like carbon dioxide's not alive, but plants take in carbon dioxide, and through chemical reactions that aren't life, they fixate that carbon into their bodies, and then a million other processes all happen, none of which are life, but from that, you get organisms. Like, traffic isn't. Traffic is sort of made of cars. Cars aren't traffic, though. So, cars produce non-cars, which is traffic. Traffic comes from non-traffic.
Right, but traffic is just a definition of a process going on. Like, we're not actually.
That's what life is.
Right, but
life is a verb, not a noun.
Right, it's a okay. So the living organism, the plant, consumes carbon dioxide, right, and creates end products, living or non-living. So the creating factor is the life. Without anything else that's not a life can consume carbon dioxide and wouldn't create a life, right? So there has to be life.
I think you have that wrong. You said life is what creates what takes the carbon and turns it into
life. The plant life is consuming the carbon dioxide. So there's life.
The organism is, but the process that makes the thing, like let's try to think of a really simple example. Do you think that a seed is alive?
If it's planted at that point, yes, because it'll start to germinate and grow, which is a characteristic of life. But if it's just
yes, but let's I can go to the Lowe's or Home Depot or whatever, and they have seeds just sitting on the shelves.
Right.
And I don't think anybody would really say that this is the closest we can get to saying those are biological things that aren't alive. They're really no different than dead things as they currently are.
Right. It's the same thing as sperm cells.
Now,
testicles.
Well,
right?
No, I wouldn't say it's the same. I wouldn't say it's analogous to sperm at all.
It is further until the cell.
No, sperm are chemically active. Seeds are dormant. This is the critical distinction. Now I need to get this part out. I don't just let me get this out here. So the seed sits in that dormant state, which is indistinguishable from death, But once temperature and the right kind of temperature, the right kind of water, and maybe some pH and when some other non-living physical conditions stimulate the seed, it starts undergoing a chemical metamorphosis and then starts to produce a living organism. But from the bottom up, it's non-life producing life.
Right. Like that's a very, I know you dismissed the whole sperm cell example, but I feel like that would be just a more complex example, right? I get the sperm cells chemically active, but scientifically, we say that life begins at conception when the egg is fertilized, right? So the
I
same way
think
when
that
the seed,
distinction is meant to point out that it's a human life,
right? A
whereas I
human
wouldn't
life
say that a
or
sperm is a human being.
right. Right. So
Yeah, but
again,
a
so
sperm is alive.
with
It's
you
not.
explaining, all of that you just did about the seed, it being at the shelves at Home Depot, you go put it in your soil, it's the right temperature, it has nutrients, starts to germinate, right? When we look at the protruding tree, maybe that came after the seed, right? Because you understand that the temperatures have to be right, there has to be certain nutrients around, right? Like you're understanding what is causing that plant life. That is very important to know that in understanding what plant life is. You don't think that it's necessary.
I'm not really sure what that has to do with anything.
Again, it just goes back to my question with the evolution when I told you, and it's okay. I even said this in the beginning. You could say you don't know. What I was asking is, do you think that maybe is important to at least know or try to know? And you said no, it's not important at all.
I
And I was just trying to
Yes,
hear how
but
it is
I
important.
I don't think it's unimportant. I think it's unnecessary to it doesn't change what we factually know about evolution and life on this planet. Again, unless you're going to invoke a miraculous creation of all life, which would entail that no life is related, then that has that's the opposite of evolution. So that's important. But just generically, the idea of where did life come from doesn't necessitate, how do I want to say this? That doesn't prove or disprove anything we know about evolution, just in principle. In principle.
I got you. Okay, so I'll move on from that. I'll ask you this second question, right? How long do you believe that human life has been evolving to the point that we're at now?
Well, it depends on what you mean by that. By human, do you mean Homo sapiens or do you mean
Yeah, like
our
if you
genus?
trace us back down, I guess to some scientists believe that life started in a sea. I guess from that, like from
Yeah, but
that
those aren't.
ancestor
Yeah, but
on
that's not
life.
human evolution.
What's that?
Yeah, but that's not human evolution because the first organisms weren't humans.
Right, right. No, I know. I'm okay. So there at one point there was only one organism, right? Or was there multiple organisms that popped up at once
There
and started
may
to
have
evolve?
been, well, there almost certainly would have been multiple cells, living organisms that popped up, but they would have been chemically very, very, very similar to each other.
Mhm.
It's possible that life popped up in more than one place on Earth, but I really doubt that. I think only one like origin of life is the universal common ancestor of all life we see today, because the odds of it being so indistinguishable, I think is too crazy to be true. So it would have been outcompeted. But
I see. And I probably would say the same thing. Now, do you think that that first organism was in the sea, in the water, or was it on land?
in the water,
In the water. Okay. From the point in time where we have the first organism in the water, how many years do you think it takes before we have an organism that has evolved out of the water? How many years do you think it could possibly be?
The timeline for Earth is in the neighborhood of 3 billion years.
Okay, so 3
But
billion
there
years.
there may have been some land fungi that only took about 2 billion years to do that.
Okay, so let's say between 2 to 3 billion years, we have the first organism on land. How much time do you think from when we have the first organism on land till now, till like 2025 now? How many years do you think it's been?
If you're talking about an animal, I'm pretty sure the number is right around 370 million years. But let me get a better number for that. Oh, it's older than that. Okay. Well, I was thinking tetrapods. Yeah, so tetrapods, it's 370 million years ago. But there are some arthropods that are on land in the neighborhood of 420 million years ago.
All right, so 420 million years ago,
Yep.
we have the first organism, and that evolved different species to now we have humans upright, walking with a mid-sized brain, can think and ration, right? So we have
Sort of, but that 420, that's not a direct ancestor. The tetrapod is, and that's 370 million years ago.
okay, okay. Let's take the 370 million years ago, right? So if we look
Sure.
at the fossils, the bones that were discovered, right? Scientists can trace our ancestors back and how we've evolved, right? We lost some of our fur. We started to walk upright.
Not really. You have the same amount of hair as like a gorilla or an orangutan. The vast majority of our hair is just really delicate and fine.
I see. So do you think in our history as the human species, we've always had the same amount of hair?
Going back even before we were in our genus Homo, yeah, we had pretty much the same amount. You have the same amount of hair that other great apes do. Like I said, they're just much more fine. There is a condition. I can't remember what it's called. I want to say trichinosis, but I don't think. No, it's not. It's not trichinosis. What the hell's wrong with you? It's called I want to say lycanthropy, and it's not that, but it's colloquially called werewolf syndrome, where the hair all over their body grows just like the hair on their head. It doesn't grow to the same length,
I
but
think
it's
I've
just
seen
as
that.
dark, and yeah, they look like hypertrichosis. Oh, okay, so I was kind of close. Okay. Anyways,
Okay, and so okay, let's go maybe 100 years back, right? I'm not too well versed in evolution, so I don't know what do you think our ancestor looked like? Maybe let's say 100 million years ago. What do you think is the difference
oh
between
holy
that?
shit, 100 million years ago. So there were mammals back then. I don't think we had proto primates that long ago, but it would have been. It's typically like if you read evolution books, like in the time of when dinosaurs were around, for the most part, they describe mammals as shrew-like animals, and a lot of that's just because we haven't found very many, and those are kind of the only ones we know about. We do know of some badger-like mammals too, but it would have been probably an arboreal, shrew-like animal that long ago. But there
Gotcha.
there definitely were mammals back then.
Right. So what do you think the main differences could be? Like what because we're evolving, right? We're changing. So what do you think like the okay, what's your number one thing? Like maybe let's say from an ancestor maybe 150 million years ago, what would the main difference in appearance be to a modern day human being?
Well, I mean, go look at what would be a good analog, because shrew actually isn't that great of an analog. They kind of look more like a cross between a shrew and a squirrel. But I mean, like, kind of imagine something that's a mix between those two animals and human beings. So, like, when you say, like, what's the biggest difference? Like, literally, almost everything is different. But at a fundamental, like, biological level, I don't know about 150 million years ago, but there are different groups of mammals. There are mammals that lay eggs today. There are only a couple left. And then there are marsupials, and marsupials are much more primitive as well. We are, what do you call us? Not eutherian. Like, we're placental mammals, but I think there's another term for that. I'm not 100% sure what it is. But I'm not sure if placentals were around 150 million years ago. So there would have been some fundamental, like, mammalian changes going on around that time. But, like, if you looked at the outside, you'd say, yeah, there's nothing human-like about it. But when you study the anatomy and the organs and the structures, then you start to see, like what are the similarities between an ostrich and the very earliest bird? Well, almost none. But fundamentally, that very first bird, it has a wishbone, it has hollow bones, it has feathers. Well, that's something that it uniquely shares with ostriches today. So that's an important, I don't know if we would call it diagnostic feature or whatever with regard to them. But
what I'm really asking, maybe it's going to make more sense now, is usually, right, when you have, for example, data, right, like how they track how some of these, I guess, I don't know. I'm not a scientist. I don't know. I can only assume, but I'm pretty sure they'll find like bones and try to recreate the image of what it may or may have looked like. So if we have maybe 370 million years of data we could look back on, right? We could track the progression of from where we were at 370 million years ago to where we're at now. That's a lot of years, right? Do you think, right, we could predict how it progresses, like backwards? Do you think we could predict how we progress in the future if all conditions stay about the same, right? Because
the conditions aren't going to stay the same. But if they did, I mean, if conditions stayed the same, then you would expect really not much evolution to happen at all. You could expect, and this is mainly because of human interference, you could expect extinctions to happen because we fuck up the environment so badly, directly and indirectly, like by like building roads directly fucks up the environment. But we bring animals and plants into environments they didn't evolve in, and that wreaks havoc and causes extinction. Like in a lot of Polynesian islands, almost all the birds are going extinct because we've accidentally brought snakes there, and there are no snakes endemic to those islands. So that's a really serious problem. But yeah, I mean, if the environment doesn't change, then you shouldn't expect to really see hardly any evolution.
So, okay, I see what you're saying. So you think the main driver of evolution was the environment changing over the 370 million years?
In a way, but there's fundamentally a way in which that's an inaccurate way to describe evolution, because the environment doesn't cause organisms to change. The environment is a filter that results in change. So, like, for example, I wrote about this in my second book, Facts That Aren't True. So, like rhinos are getting poached in Africa.
Mm-hmm.
So what you'll see sometimes is headlines will say poaching is causing rhinos to be born without horns. That's not true, because what that implies is somehow either nature or the rhino knows, understands, can feel that if they have horns, they're in danger. So they will themselves, or the environment wills them to be not born with horns. That's not what happens. What happens is there are mutations that can spontaneously, randomly, unpredictably, at any time, cause a rhino to be born without horns. But then they don't get poached. Meanwhile, all the other ones get shot and killed. So the rhinos without horns start to become more common, and people without like bad intention or anything, people accidentally frame that in a way that's technically inaccurate. It's an orthogenic view of evolution, which we know is false.
I see. I see. So I guess, and I was asking this out of curiosity, right? Because like how with AI, right? Because AI has a lot of data, how faces evolve over time, how things change, the faces shape. If you have a picture of, for example, a child, right? Like you could put it in AI and it could predict how that child would look 20 years from now. So my question was, do you think evolution can predict what, let's say we got rid of the nuclear weapons, we didn't extinct ourselves. Let's say humans survived another maybe 200 million years. You think would have any like physiological changes in how we look?
Humans, I really kind of doubt it, because we're just not we're not subject to natural selection hardly anymore. It very well may be the reason that certain things are becoming more common, like like diabetes, perhaps autism to a certain extent, and many other things. So, but whatever change that could potentially like lead to or whatever in the human species, we would just mitigate or cause whatever changes we want with technology anyways. So I just, when I think about the future of human evolution, I kind of just throw my hands up and I say, I don't really see any morphological changes happening with us. The only thing could maybe be humans might start to become more, I don't want to say normalized, but what would be the word to call it? More standardized maybe in a way, because if we start to, like, through technology, we start to discover what is good and bad, healthy, unhealthy for us, and we start intervening that way, then that I would guess that is going to make the human race kind of more similar. I mean, it could be like that episode of South Park. I mean, it could be that in the future, ethnic groups are just almost non-existent, or there's going to be the variation will be extremely subtle, because if we're moving around so much and populations just have intermixed so much, homogenous. Yeah.
But see,
How did
wouldn't
how
that
did I
be the
not get
same
that?
thing as what the rhino is? Like because you're saying like the rhino gets poached, right? And you said it's not like nature, the environment knows, right? So like how, like, you know what I'm saying? So like if we were doing certain actions, right, we started doing things differently because of technology. With the rhino, you said it's just a random mutation that occurs. It's not like because of what's
Yeah.
happening to it, it being poached is what's making it not happen.
Yeah, but like as a human being, you can literally be the slowest, fattest, dullest, dimmest tool in the shed, and it doesn't affect your survival. In fact, he's president of the United States right now. So the consequences of that just aren't really, we're not at the mercy of them.
Right, but I guess what I'm trying to make you see is, right, when you describe the rhino, right, and it getting poached, you found it hard to think that the environment would know that this is going on to it. It's you actually said it's really the gene mutation, a random gene mutation. Or I don't know. Can you say it again? How you said it? I don't want to
The way
misquote you.
you said it's fine. Yeah. You can't predict what kinds of mutations that are going to subtly alter the organism are.
Right. So then we wouldn't predict what type of mutations a human would have, right? That would then like make us evolve into something completely.
But the thing is, in the wild, the variation that you see in a species is really important, because a subtle variation that makes an organism more fit for its environment, which just means makes it more successful and more likely to reproduce, that proliferates through the environment because of the survival advantage it has. What I'm telling you is for humans, like it doesn't matter if you're 7 feet tall and a super athlete freak, or 5 feet tall and kind of a moron. Your odds of surviving and reproducing in the modern world, thanks to technology, are the same. And so I don't see the human species going in any particular direction, but probably just becoming more alike or more homogenous is how we would say that.
Now, so you don't think that with the 370 million years, right? We don't have enough data of how like our ancestors mutated and what caused the change. You don't think we have enough data to predict maybe even like 50 years in the future based off 370?
No, because you can't know precisely how the environment is going to change, and then what if you don't know how the environment's going to change, then you don't know what the best adaptations or advantages would be. But also,
Okay, so for example, right? Don't you think when for example global warming, right? Don't you think that scientists predicting what the conditions of the Earth will be, at least in the next maybe 50, 100 years? Like even when you
yeah,
pull up the weather, right? You could predict based on data again, right? You can predict in the
yes, but
future a
no,
little bit. If you have enough data, you could predict a little bit in the future.
yeah.
That's how we
So
get like the weather, and we even know like the world is getting warmer, and it will be warmer. Or
yes.
you could argue or disagree with that. But
Well,
just
the
I
problem
think
the problem with that is there's more than one way to skin a cat, right? So human beings, I don't know if you know this, but do you know where the best long distance runners in the world are from?
um I want to guess just because of TV, probably Africa, because I see they run a lot.
Yes, but more specifically, Africa is the most ethnically diverse continent on the planet. So it's not just like South Africans are not great distance runners.
Right, it'd
Egyptians are
probably
not
be
great distance
Kenyans
runners.
maybe.
It's yes, it's Kenya and Ethiopia, but it's even more specific than that because Kenya and Ethiopia are highly diverse ethnically. I think they're called the Kalenjin tribe that sort of overlaps both countries. From just that one tribe, something like 18 of the 20 fastest marathoners in the history of the world have come from there, right? Now, there are lots of reasons for that, but one of the most significant reasons is because it's very high altitude. So their bodies are just more efficient at using oxygen, so they have this athletic advantage. But it's not like that's the only high altitude place in the world. Where are all the marathon runners from Tibet, which is the highest altitude country on average on the planet? There aren't any. Where are the ones from Nepal, where the Himalayas are? There aren't any. Where are all the ones from Chile, where the Andes Mountains are? There basically are none. Or Peru, there are essentially none, right? Because people that live in those high altitude places, they have different physiologies that let them in each of those three places, there's a difference. In one, they just have really, really thick blood, so they can gobble up more oxygen. In others, it has to do more with their respiration and the way their bodies cool down to be more efficient. And I can't remember what the other one is. But so if the environment changes, like let's say it gets colder, well, what you could do is you could evolve to be hairier, or you could evolve to just be bigger because a bigger organism traps more of its heat. Or you could evolve to start living underground where the temperature is more stable. So any species could do that because there are mammals that are gigantic and not hairy. There are mammals that are medium-sized and very hairy. There are mammals that live underground. So and it's true for all kinds of living things too. So you can't really predict what's going to happen because of how many different possible we would call them like niche exploitations or niche explorations are possible. And oh shit, what was the last thing I was going to say? And well, I forgot. There we go.
That's okay. But I guess to follow up on that, I would ask this though, right? Like when you said if it gets colder, right, you could evolve to have more hair, or maybe you could get bigger, right? If you add another data point in there, maybe you look at how, based on the species that you're talking about, maybe how good they are at getting food, or based on where they are, how much access they have to food, right? If they have very little, for example, it'll probably be more likely that they would evolve to have more hair than be bigger. Don't you think so?
No, and actually, JK right here in the comments brought up something really brilliant. The hyrax and the elephant have a common the hyrax is most closely related to the elephant. It's not the other way around. For elephants, I think they're most closely related like to manatees or something like that. But so the hyrax and the elephant have a common ancestor. So a long time ago, the great 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 whatever ancestor of the elephant and the hyrax was the same thing. But and they live on the same, hyraxes live in Africa too, but they somehow diverged for one to be this chunky, really cute, almost like a, I don't know, what's the closest thing that they, kind of like a badger mixed with a prairie dog or something like that. I don't exactly know. And then the other one, I don't need to tell anybody what an elephant is, right? So no, there's no reason why one became what it did versus the other, but that's because, and I actually remembered what I was going to say earlier, that you can't predict what the spontaneous changes are going to be, and so the population just has to work basically with what it's given, and it gets driven by natural selection in that direction based on that.
I gotcha. Well, again, thank you so much. Really, I just had those questions, but thank you for being polite and you know, answering my questions. I guess all I was going to is I'm very curious, so I just thought it would be really cool, like if scientists could like create an image. I know they could be wrong, like even when we predict the weather, it's probabilities, right? Based on the data we have. So it won't be like you can't have a definite like it'll be like this, but I just think it'll be really cool if we had like an image of maybe you could have multiple images based on how we go, right? And the probabilities of that.
This was done a long time ago. There was a TV show called The Future is Wild, and it aired back in 2002, and they made some really wild speculative biological claims. Like they have octopuses that now live on, or squids that now live on land and are like the size of elephants, and then they have other like squids or octopuses that live in trees like monkeys do. So they went absolutely batshit crazy with their speculation. The CGI is really terrible because it's from 23 years ago, but check that out on YouTube. And then all we have to do is wait 100 million years to see if it comes true.